Hello everyone, welcome to the first video of my channel. I have completed the Google Data Analytics course from Coursera a while ago, and would like to share my thought process and what I have learned on data analytics through a Capstone project using a case study provided by them. I hope that this helps you if you are stuck in the course or if you require some reference or guide on what others have done. For the purposes of data analysis as taught in the course, I will be using the R programming language. Without further ado, let's get started. Here is some background information on the case study. You are working for Cyclistic, a bike-sharing company. Bikes can be unlocked from one station and returned to any other station in the system anytime. Cyclistic has flexible pricing plans, single-ride passes, full-day passes, and annual membership. Customers who purchase single-ride or full-day passes are referred to as casual riders. Customers who purchase annual memberships are Cyclistic members. The marketing director believes the company's future success depends on maximizing the number of annual memberships, as finance analysts have concluded that annual memberships are much more profitable than casual riders. She also believes that there is a good chance of converting casual riders to members, as they are already aware of Cyclistic's program and have chosen it for their mobility needs. You are tasked with analyzing user behaviors on how annual members and casual riders use Cyclistic bikes differently to make recommendations on how to convert casual riders into annual members. I will be using the 1-month dataset made publicly available by Motivate International Incorporated. The link to the dataset will be shared in the description box below. Due to data privacy issues, I won't be able to connect pass purchases to credit card numbers to determine if casual riders live in the Cyclistic service area or if they have purchased multiple single passes. Next, I will install and load the packages in our Studio Cloud and read the file from there. A heading and summary of the dataset can be seen from the screenshot. From the column headings and data available, we can see that there are 13 data columns available, and I can infer the following metadata. Ride ID, which is the unique ID of each trip ride. Rideable type, the type of bicycle ridden split between 3 categories: classic, docked and electric. Started at, which is the date and time of the start of the trip. Ended at, which is the date and time of the end of the trip. Start and end station name, the names of the starting and ending stations. Start and end station ID, the unique ID of the starting and ending stations. Start and end lat, the latitude coordinates of the starting and ending locations. Start and end LNG, the longitude coordinates of the starting and ending locations. Member casual, the type of membership, which can either be casual or member. Something to note that I have spotted from the metadata is the data limitation due to no personal information available. I am unable to tell how often the same user uses the bike in the month and how frequently, and from which stations. Hence, I can only make the assumption that each ride ID corresponds to a unique rider spread across the days of the month. We can then proceed to start by processing the data. I start by removing duplicate records if any, and remove records with NA values. I will also create 3 additional columns for more data analysis. I will create a new column for trip duration min to compute how long it took for the cyclist to complete the trip from start to end station in minutes. Weekday for which day of the week the trip took place. For example, 1 corresponds to Sunday, 2 to Monday, and so on and so forth. The last column would be trip DISTKM, which is to compute the distance between the start to end station in kilometers. Right away, under the column trip duration min, we can see that there is an outlier data. The maximum trip time spent is 47,776 minutes, which is approximately 33 days. This might be a data error, or the person simply rented the bike for a month. We might perform winsorization later depending on the data distribution to remove such outliers, as this would be uncommon and might skew the data significantly. Next, we can inspect the stations with the highest footfall for start and end stations as well to see if we can glean any additional information. From the table results, we can see that there are quite a number of records with blank start and end stations. This might be a data quality issue that requires additional investigation subsequently. However, we can see quite a number of recurring stations with high footfall from casuals. They are as follow: Lakeshore Drive and Monroe Street, Streeter Drive and Grand Avenue, and lastly, Millennium Park. We might want to pay more attention to the above stations with greater footfall of casual members. Next, we can also further drill down additional information for those with blank station names. From the table results, we can see that blank stations are mostly due to electric bikes, with a few records arising from classic bikes. This might be a data issue point that the operations team need to address in future, and requires additional investigation why the station names are not populated. It could be because the bikes are returned near the stations but not exactly at the stations, and hence the blank records. I will then check the quantile values and perform winsorization on the data. As seen from the quantile values, there are outliers for trip duration min, and I will perform winsorization, defaulting the high outliers to a specified value of 1000 minutes, which is approximately 16.7 hours. We can make an assumption of bike rental for a full workday. For the trip DIST-KM, the distances appear to be normal and feasible, hence no winsorization is required in my opinion. Next comes the more interesting part of data visualization. First, I will plot a scatter plot chart of trip duration against trip distance. Majority of the cyclists cycle for less than 250 minutes, which is approximately 4 hours, with the casual cyclists seemingly cycling to further end stations compared to members across the various trip durations in general. There is also a high number of casual cyclists stopping at the same station that they started, hence zero distance covered. Looking at this, naming it trip distance is a misnomer, as it is possible for cyclists to cycle long distances, but the end point ends up near the start point or even the same start point for various reasons. Also, there appears to be a high number of casuals who took greater than 1000-minute trips. This would probably warrant further investigation. I also took the liberty to plot a facet grid chart of weekday usage by membership and rideable type. From the chart, it is clear that there is a strong preference for classic bikes for both casuals and members, followed by electric bikes. There are a few casual cyclists who choose to ride docked bikes, but no members riding docked bikes. There is also increased usage over the weekends from Friday through Sunday for casuals, but fairly consistent usage by members across the days apart from a spike on Friday. Finally, I will also plot a facet wrap chart of weekday usage by membership and rideable type. This actually provides somewhat similar information to the previous facet chart, but presented in a slightly different manner. In conclusion, based on the above analysis, there are no clear recommendations on how to convert casual cyclists to members. But there are some follow-up leads which warrants further investigation, which may lead to conversion. Firstly, there are several limitations in the data provided. Since there is no personal information available, we are unable to tell how often the same user uses the bike in the month, and how frequently, and from which stations. With such information available, we might have better insights into user behavior. Next, there are blank data points for start and end stations and starting and ending longitudes and latitudes. This is a data issue which requires further investigation, as there are quite a high number of such missing data points. With more complete data, we can have a better analysis. From the data analysis, we can observe that there are a few start and end recurring stations with higher footfall among the casual cyclists. We can put up targeted advertisements on those stations, or have a personalized advertisement via the cycling app for discounted membership subscription promotions for cyclists using those stations more frequently. We can also see that casual cyclists cycle to further stations and take longer in their trips. Depending on how the subscription package is sold, we might be able to use this to sell promotional sign-up packages to the casual cyclists. There is also a high number of casual cyclists who take abnormally long trips. This requires further investigation to understand why this is the case, and hopefully draw some insights which may help to convert them to members. Lastly, there is an increased bike usage among the casuals during the weekends, from Friday to Sunday. We might consider increasing rental cost over the weekends for the single and multi-passes, such that it might be more worthwhile for the cyclists to switch to member subscription instead. All in all, it was an interesting capstone project, and it is quite realistic for professional data analyst practitioners, whereby the data is quite open-ended and dirty, and you have to make sense of the data based on the limitations and constraints that you face. I would highly recommend anyone who is interested in data analytics to take the course. So, what are your thoughts on it? Feel free to comment in the comment box down below. If you liked this video and would like to see more content of this nature, please be sure to like and subscribe as well. Thanks for watching, and until next time.